Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Automating diverse file types embedding in Langchain. Implementing incremental vector storage in Faiss. After we do the embedding of the files, we need to store it somewhere. So that storage is going to be Faiss, and we are going to discuss how to do these two in this particular discussion. So the goals, there are two goals. We have to embed various diverse file types like text, PDF, CSV, that is comma separated or tab separated files, Excel files, code, that is Python, JavaScript, and finally Jupyter notebooks, IPyNB notebooks. After we do the embedding, we need to incrementally load the embedded vectors into Faiss index. This is the discussion of the video, the steps that we are going to achieve. First of all, we need to realize that the data is stored as text, whether it is PDF file, whether it is the IPyNB notebook. At the end of the day, internally, whatever we provide the information is stored as text. Yeah, I am not talking about the pictures, the PDF files, and also some IPyNB files can contain pictures, and also you can embed different kinds of text related pictures also. So if you are talking about pixel art, then we can embed art into text also. But we are going to talk plainly about text embedding, and the files that we are discussing here, the text, PDF, CSV, Excel, code, IPyNB, finally these files actually store text inside them, but they store the text in such a way that it is useful for certain purposes. So the PDF file has its own benefits for publishing, for sharing, for printing, while CSV file is useful for working with using it as a sharing medium between multiple machines, or multiple programs. Like if you are taking from Spark program, you can actually move it into Python program very easily using pandas library. Like that, we have Excel. There is no need to introduce Excel, and all this, even the code, the Python, the code that we are going to write is still a text, but yeah, it is written in certain format with line breaks and gaps, and also tabs. So how to read them, how to work with them, we will be seeing it in this particular video. Next, we need to understand how the file loaders work in Langchain. So that is something that I'll be giving you a brief. I'll be showing you how to check the file loaders for your understanding. Also, I'll be discussing the difference between the plain text elements and the document elements. I'll be showing you some of the information. We need to extract the text from the files, and then we need to split them. Most of the time, the inbuilt splitters that is available inside the file loaders are not sufficient. So you might have to do additional task on top of the loaders. So for that, we'll be using recursive splitter. We need to feed them to the embedded functions after we do the splitting. And then we need to add the index. So index, by the way, the vector store is also called as an index. It is a data structure in which you can add the new data by appending. It's like similar to a Python list. We have to modularize the code. After these 4 steps, after you have understood all these 4 steps, we have to think about how to modularize the code, refactor it into functions, and make it easy for you to use it in various scenarios. So we will be discussing, because at the end of the day, this particular video is part of the series where we discuss about automating with artificial intelligence, and we are trying to use these technologies in real world, in real time, for working with our files that is available in production. So you need to modularize, you need to test the output of these functions before we go into production. And finally, we need to search the vector store. So we are incrementally updating the data into the vector store. So finally, once the vector store is ready, it will contain lots of different information, like from the code, from the text. Also, here I have not shown one of the points. We can actually load the files from the GitHub repo directly also. So I'll be showing you how to do that. I have not mentioned it specifically in this goal because it's part of the code, right? So we will be looking into that. There is a loader for that also inside Langchain, and it is pretty neat. It uses Git Python library. With all that said, let us dive into. Let us first understand what is Faiss. Faiss is actually abbreviation of Facebook AI similarity search. In fact, there is no AI in similarity search. So it's basically cosine distance, or a kind of a mathematical distance between two vectors that we provide. That is between the query vector and the document vectors. So if you're totally new to this kinds of concepts, I would like to direct you to this particular playlist inside my YouTube channel. So I'll be discussing about various types of applications of artificial intelligence models that is used in real world. So that is the main objective of this playlist. I'll be discussing all the concepts, and also there are other playlists that just a minute. The playlist on Hugging Face NLP and Mastering NLP series. So here I go deeper into the various models available, various ways of embedding, various ways of interfacing with the AI models are explained in this particular playlist. So take a look at this also. So if you're new to all these concepts. So let us go back to the discussion at hand. So what is the flow that we are going to follow? So first and foremost, we need to extract the file data to text. We need to split the file data using splitter. We need to embed the data, and then we need to check if there is an index already existing. Then we need to merge it with it, or else you have to create a new index. This is the flow that we are going to follow for all the files. We are going to use Faiss, as I already told, but there are other open source databases also, like ChromaDB, pgvector, Quadrant, Annoy, HNSW, and we have Elasticsearch, we have OpenSearch. So there are lots of other vector stores, but Faiss is very lightweight. It works flawlessly, and it is used by most of the people right now. So that is one of the main reason why I wanted to concentrate on Faiss, and it does not actually add unwanted features. So Faiss cannot do lots of hybrid search and all those stuff. So it does not add those things, but Faiss can stay right in with your code. You can actually store it in any of the locations that you want. You can load it very easily. So I'll be showing you all this stuff. If you are new to Langchain, that is something that you need to be aware. Just a moment. If in case you are new to Langchain itself, so I would really suggest that take a look at this particular video so you can come up to speed with Langchain. And I have discussed in detail about the various loaders, the various ways of embedding, the various ways of working with Langchain and with document embedding. So these videos will make you come up to speed. Here I also compare the various vector stores that is available in the open market, and so all these discussions are happening in this, especially in this video. You can take a look at this. So what I am trying to do here is to give you an overview of what is available, and so that you can and then actually drill down into the detail, because this particular video is going to go into very much detail about this particular goals, that is taking the text files and working with them to embed it inside the Faiss vector store. Now, without further ado, I would like to move into the coding. Each file types have their own unique challenges. So we need to understand that also. That will be what I will be discussing next. And whenever the code is getting embedded or split, so before we actually embed the text or embed the data, we need to split it. The way you decide to split it is very, very important, because that is what is going to decide how it is going to be retrieved. You will be seeing that in action in a couple of minutes. This is a challenge that most of you must be facing already. So you will get some ideas on how to resolve these challenges. With that said, I hope that you like this content, and do leave a like, share it with others, and subscribe to my channel for further updates on similar videos. Now let us go to the browser back again, and now just a minute. Yeah, let us go to the browser back again. So the code, this particular code will be shared with you guys over the GitHub repo. So once all you need to do is go to the collab environment or your own. This particular code can work in your local environment also. So you don't need to worry about that. You need to use only, just a moment guys. So let us start working on the code. So we need to pip install couple of libraries. So I have listed the libraries here: the Langchain, Faiss CPU, PyPDF, Git Python, OpenPyXL, and sentence transformers. All these will have their own dependencies, which will be taken care by pip. So you don't need to worry about that. In case of the notebook, I have added a couple of other libraries like transformers and llama cpp. That is because if you want to explore further with different embeddings, yes, you can try that also. That is why I have added it here, but I am not going to concentrate on that. Now, these are the various files that will be converted, that will be worked with, as I already introduced. And the files that will be converted or that will be used is already shown here. Okay, I'm showing it to you guys so that you can actually refer to this when you are trying to load the files. Like all these files: Vim play, space shortened, self ask, this multiple file embed Faiss is the same notebook that I am right now working upon. So I am converting this IPNB file into Python file. That is a process for this. I will be telling to you. This mail collector.txt, this is the file that I used from the earlier video, where I collected the mails from Gmail and I did the embedding and did the work with that. And this is the data in Excel is also available in the same repo. So all these files, the data is available inside the same repo where you will be finding this particular code. So you don't need to worry about, again, it's not that you need to work with the same files. When you are trying to work with the examples, it is better to work with the same files at the beginning, when you're trying to go through the code and trying to understand it. Once that is done, once you are through with the example, then you can try working with your own Excel files, your own data files. The reason why I'm telling this is that once you have found that, okay, the code that has been explained to you is working properly and you're able to make it work, then it is a matter of trying to tweak with your data. So I hope that you understand what is going on here. And let us dive into the next step. Okay, the various modules that needs to be imported is shown here. So we are going to work with Hugging Face embeddings and sentence transformer embeddings primitives in Langchain. We'll be working with recursive character text splitter because it's more easy to explain what is going on. And Faiss is what is going to be the vector store. We have multiple document loaders here. So CSV loader, we have PyPDF loader, data frame loader, and Git loader. And then we have NB format, that is notebook format module import, which helps me to convert the notebook, IPNB notebook, into Python code. So you'll be seeing how to use it. Right, these are the various introduction about the modules. Now comes the first easiest embedding or first easiest file type, that is text file. So text file is the most easiest because what happens is, so here I have already modularized the code. So if you see, if you actually review the entire notebook, you will see there are lots of functions like get text splits, and then you have get PDF splits, we have Excel splits, we have CSV splits, we have IPNB splits, and finally we have Git files and embed index. So I have already done the modularization. Let me go to the PDF for a moment. I explained in the goals, that is in the steps, that after we understand the 4 steps, this first 4 steps, then we do the modularizing. So I have already done the entire research on the first 4 steps, the first 5 steps, and then I already modularized it. Now what I'm going to do is, I'm going to explain to you from the modularized code only. So that will be much more easier for you to understand. But if you are going to tomorrow try to do the same task, then it will not happen from here, obviously. So you will start from the beginning. So you will work on file loaders, you will work on splitting, you will work on embedding them manually and trying to understand how it works, and then you will modularize it. That is how I did it. So sometimes when we do programming, if you are new to programming, that is, that we feel that the functions came into existence in the mind of the programmer as it is. Actually, no. The programmer actually does a lot of research, understands the steps involved, and after he does the trial and error, he clubs all the code together and creates the function. That is how the functions are created. Yeah, after you become more experienced, after you have tried that particular application or that particular service a lot of time, then the coder can immediately, or the programmer can immediately come up with the functions and class primitives directly. But in the beginning, when he is training himself, trying to understand the library, the module, or the summer or the service, it is going to be a very simple process of understanding each and every step, and then clubbing the steps together and converting them into functions. So this is the process that I have followed. Let us go back to the present, the notebook again. So what I did when I started the research in the morning today, I was looking at the steps. So what are the steps I need to take for converting the text files into embeddings? First and foremost, I need to read the text file. So this is a simple read process that I am following. And then I need to initiate a recursive character text splitter class that is available inside Langchain. This is the easiest part. So I am using a chunk size of 150 and a chunk overlap of 15. So what is chunk size? The 150 chunk size is actually the number of characters that will be in each document or each split. And the overlap is the overlap between the end of the document and the new document. So if I say chunk size of 15, so 15 characters at the end and the 15 characters at the beginning of the next document will be overlapped. So assuming that this is one document and this is another document, right? So this is how the text splitter, the recursive character text splitter works. This is pretty intuitive once you understand the chunk size, the chunk overlap, and the length function. So text splitter takes the length function. This is Python's length function. This is why I use recursive character text splitter is it is very repetitive. Whether you are going to use whether you are going to use the data in XLSX or mail collector.txt, when you are going to convert these files into text data, the recursive character text splitter is going to work in a predictable fashion. In case of other kind of text splitters, it was a little difficult for me to understand, like character text splitter that is already available. I was not able to intuitively understand. Sometimes the character text splitter was not reducing or splitting the text in the way that I wanted. But in case of recursive character text splitter, it was spot on. That is the reason why I chose this. You can actually play with this, so there is no restrictions. At this moment, I am only taking the text file as the input. If you want, you can create the function in such a way that this entire text splitter class itself or the instance itself, you can actually send it to the function and then you can use it. No one is going to stop you, right? This is something that I have preferred. I felt it is okay for me. And each of the function, you see, in each of the function I have initiated it separately. The reason is, there is a reason for that. I will explain to you in a couple of minutes. Okay, so you do the text reading. Once you read the text, it comes into the Python execution environment as an object, and then you send the object into text splitter, and you will get a list of text. Let me show you how the list looks. So I think I already have the list somewhere. Let me show you in a moment. Next, what happens is, so here you see some of the examples. So what I've done is, we are going to talk about the PDF splitter next. So what I've done is, I have first of all taken the PyPDF module, the PyPDF loader, and then I have sent a simple PDF file. It is having 31 pages, and I sent this file into PDF loader, and I use the load and split method, and then I checked how many pages output I'm getting, so or how many elements I'm getting out of this PDF loader, and I got 31. Right, I have named it as pages, okay, but this is 31 elements. It's a list. If you take a look at the list, so for an example, if I take a look at the first element of the list, you will find that this is actually a document. It's not a text data. So this is inside the document, and if I use this kind of a primitive page content, you will see that I can get at the text of the PDF document. Okay, this is how the internal primitives work in Langchain, and you see how big this particular first element is. This is a very huge file. This is a very huge data, and assume that you take this entire data and convert it into embedding, and then load it into load it into Faiss, and later you do a retrieval inside the large language model like OpenAI's Chat GPT. What will happen is this entire document. So if this entire document gets selected, then you will be out of token, right? Because there is lots of data in this, and if this particular documents get selected completely, then it cannot be used in the large language model. That is something that you guys will be facing. So also another one challenge you will face is that whenever you are going to use such a big document, and when you provide a small query like let us say what is self ask. So you just want to know what is self ask, and you will not find any documents at all. So you will get a error telling that there is no document matches. So that is because that the way you have done the embedding, the way you have split the document is not correct. So, and in order to understand what is not correct, it is because that when you are say for an example, this entire page talks about lots of topics like compositionality. It talks about reasoning. It talks about prompting. It talks about lots of different topics. And when you are going to ask, okay, what is self-ask? So let me go down to the end. Okay, I have got some examples, so I will show it to you. I'm going down to the end, and here I ask, okay, what is self-ask? And let me zoom in a bit so that it will be easier for you guys to view. Yeah, I'm just simply asking what is self-ask to the index, and I get 4 different output, and all these 4 different output have something related to self-ask. I mean, it contains the word self-ask in that particular document, right? And you see that this particular piece of sentence can come from any part of the 31 pages that, just a minute, let me go to the top. Any part of the 31 pages that gets loaded here, any part. And if there is no any match at all, then what will happen is when you are trying to work with the large language model, you will get the error that there is no matches. So this is the challenge that most of you guys are facing. So you need to first of all take this page content, and you need to split this page content into multiple smaller parts, like how I had shown in the bottom. So that is why I had taken this particular example here. Okay, we were discussing about we were discussing about text loading, and I also introduced you to the PDF loading, and both of these steps finally actually load only text, right? So understanding how the recursive character text splitter works and how the text is getting split is the important step. When you try to use recursive character text splitter, the output will be text only. So keep this in mind. You don't need to keep it in mind. So I will explain to you how to avoid that pitfall. So there are 2 kinds of outputs that come from the text splitters. Langchain text splitters. One is document and another is text. Text is simply strings, and document is what you saw here. So it will have a page content key with it. So there are only 2 types of elements. Why I am talking about this I will explain in a couple of minutes. So in case of get PDF, I am again using the same things that I researched here. So I understood how the PDF loader works, and I loaded the pages, and now I am again initiating a recursive character text splitter. So why am I having separate recursive character text splitters in each functions? Because you can control the chunk size and the overlap the way you want. If I created a single element, a single variable outside, and I pass it here, it might be difficult for me to change it every time for each of the file types, right? So that's why I created the recursive character text splitter inside. Also, as I told you, can send this entire instance, character text splitter instance, as a argument to this function also. So that is one of the ideas that you can implement. After that, what I do is I create a separate element, empty list element, and then I enumerate each of the pages that this particular PyPDF loader provides me. So this PDF file can be any PDF file. Once this PDF file is loaded, it is split into multiple pages, and each of the page has text, and then each of the text is split using split text. And you see this, that I am using split text and I am using page content here, because the split text method can work only on the string data, not on document data. So that is why I have to use the page content attribute here. Once that is done, so you see the process, so you will get a doc list again. Same way, how you got a doc list in text, the get text splits, the same way you will get the doc list in PDF also. Only the additional step is how I load it in how I load the PDF. Now comes Excel. This is little bit different. So when it comes to Excel, there are a couple of things you need to be aware. So Excel file format is not an open file format, right? It is created by Microsoft, and the way to interface with Excel is through OpenPyXL engine inside Pandas library. So this is the way I am reading in the Excel. So this is the Excel file path, and this is the library that I need to import. I mean, I don't need to import the engine here. You can install pip install OpenPyXL and it will work. And then you need to provide the sheet name. So sheet name can be a string or it can be a number. All this input I need to provide here: the path, the sheet name, etc. When it comes to when I load it in Pandas, I get a data frame out of the Excel file. So this becomes a Pandas data frame, which is a Python variable. Now, to load the data frame, there is something called as data frame loader in Langchain. So this data frame loader is a Langchain primitive. And when you are going to load this data frame into Langchain primitive, this will actually split the data. So that is what the loader does. But you need to provide the target column here. So this particular target column you need to understand by opening the Excel file and deciding which target column you want to use it as document, and the rest of the target columns will be metadata. I'll be showing you what is this in a couple of minutes. Okay, so let us go with the flow, so that later I will explain the examples. I have a couple of examples also. Next is the get CSV split. This is one of the easiest splits that I've ever come across. What happens in this case is that there is a CSV loader in Langchain. All you need to give is the CSV file path and load it. The document CSV loader in Langchain splits the CSV files into rows. So each row of the CSV file becomes separate documents, and it is pretty neat. So, and also it actually does a different thing. So it does not actually split the rows directly. So it converts the rows into a certain format in such a way that each cell or each data element inside the CSV file is near the column name. So what I mean by this, let me show you an example that will be much more easier rather than confusing you. So let me open the space shortened. This is one of the CSV files that I have. So this is the cell value. So Europa is the cell value, and this is the column name. When the CSV file splitter or the loader actually creates the documents, what happens is it converts this entire CSV file in such a way that each cell value is adjacent to the column name. So what I'm trying to say is that the first row will have passenger ID colon this particular 00001 underscore 01 and home planet colon Europa. So it will be kind of a dictionary or JSON format, and then that JSON format will be split into rows. So I'll be showing you the example. This is one of the important points that you need to realize, that when you are going to work with the vector stores only provide you the similar data, and the large language models have to look at the data and find out that, okay, what I am find out to reply to the user query. So the data has to be proper, right? Assume. So let me go to let me open the space shortened file again. Assume that I am asking the large language model, after providing this particular file, I am asking, okay, who went to Trappist destination a lot of time, okay, or which particular planet, the home planet, has lot of people going to Trappist. Now what will happen is, first of all, large language model has to find out the destination, and if the destination is only there in one part of the document, okay, it will be lost, correct? If it is only at the top of the document and if it is nowhere else in the document, then what will happen? It will not be able to find out that, okay, this destination is linked with Trappist. So to avoid that, they have the JSON format is very useful. So you will be seeing that example in a couple of minutes. Next is working with IPNB files. So this is where a little bit of interesting things happen. What happens is there is something called as I already introduced the modules, right? NB convert module. In the NB convert module, there is a class called Python exporter. So the NB convert module takes the IPNB file format, it reads it, takes the data, converts this into the code format, and then keeps the code in source element, this particular variable. This particular variable contains the text, that is the code, the string that we type, this string that we have typed here, the Python exporter, open and close bracket, this is the string data that we have typed. So all this will be inside the source, not just this particular class. All the code that is inside this particular notebook will be inside the source, and then I'm using, as usual, the recursive tag character text splitter and sending the source to split. And this is not the right way, okay? I'm telling you ahead of time. So there are various ways to work with the code document, because the character text splitter blindly splits the document. But if it is a code, like if it's JavaScript, or if it is a Python code, or if it is a Rust or a Golang, the code has a certain format or the certain parsing method that is already available. So if I use a blind recursive character text splitter, then most of the code I will be losing the relationships. Like for an example, there could be, so for an example, I would have done an import. So on top of, so let us take an example. So on top of this, I would have done an import, and this particular import may not be linked with this particular variable. So there will be disconnect. And how will the large language model be able to find out? And if I am going to ask about Python exporter, so how will it be able to find out that, okay, I am talking about the Python exporter in this function, or the Python exporter that I am showing here in the import area? It cannot find the relation, correct? So that kind of troubles can be avoided when you are going to work with appropriate methods. So you need to understand these things also. So these are all something that I am telling you the pitfalls, but I am not directly giving you the solutions. Right, you need to be aware of this. So if you find such issues cropping in when you are doing the similarity search, when you are doing your coding, then you need to understand, okay, probably this is the problem. And then we do the text splitting. That is about how we work with IPNB files. Now comes the interesting part. So in case of Langchain, there is something called as Git loader. So this particular loader can take the repo, any repo, Git repo that you are going to give. It takes the repo link and it actually goes into a folder that you want to work on. And inside the folder, you can actually give the file filter. So if I want Python files, you can look for only Python files. If you want only IPNB files, then you can give the extension here. The extension should be like in the form of .py, .ipnb, like that. Once you give that, then this Git loader will go into that folder, bring out the files, and then each file will be a separate document. So this is very important. Each file will be individual document here at this in this variable. So it will be a list variable, and then again you have to the document will be text format. You have to use the character text splitter. The same process you need to follow. So let us go back to the PDF for a moment, because we have actually understood how we have realized the data is stored as text. We have learned how the loaders work. We have decided how to extract the text and split them. And next, we are going to feed them into embed function. So we have seen how to work with text, PDF, CSV, Excel, code, IPNB files, right? All these things we have done. We are good to go, right? We have a couple of things more to understand before we start rocking. If you have to embed, if you have to create the vectors from the text data, we need to have a function. We need to have an embedding model that we are going to use. So there are lots of models that is available as open source in Hugging Face Up. As I showed the earlier As I showed in the earlier playlist, you can go to this playlist and you can find a lot of discussion about embeddings. You can find a lot of discussion about how to get access to these functions. In case of Langchain, there is a primitive called as Hugging Face Hub embeddings or sentence transformer embeddings. We'll be using that, and that particular embedding will give you a black box to which you can give text, and it will give you out the vectors. So that is the embedding function. In case of OpenAI, you have OpenAI embeddings. That embeddings is not in your, that is not stored locally. It is in the OpenAI's server, so you cannot access it. But in case of the embedding, open source embedding that is available to you, can be loaded locally also. This is the main difference that you need to understand. The process to follow, there are two ways to do the embedding. So either you can use, first we need to initialize Faiss. This is the module primitive, Langchain primitive, and you can load the documents directly along with the document list. So you saw all the get files functions return document list. So some kind of a document list it will return, and each of these documents will contain text elements. This particular, where is it? This particular function, let me zoom out a bit so that it will be easier for you, because I'm scrolling up and down a lot. Here you see that there are two ways. Either you can use from documents or you can use from texts. Why I'm doing this? Because as I explained, in couple of the functions, you will get the document list containing text, and in couple of, like for an example, in case of CSV splits, you will get documents as the elements, not text. So at that time, it can be a little confusing. So what I have done is, in this case of embedding index, I have tried it. So first I try to load using from documents. If it fails, then it will go to from texts. So this is one of the hacks that I have done. So anyway, at the end of the day, when you send the data into any of these methods, you will get the embedding done. This embedding function, I will show you how to initiate it. This is the first part, right? This is the part where you are just embedding and keeping the embeddings inside the Faiss in-memory index. This particular line, or these two lines will create in-memory indexes. In order to make the index into index to persist, you need to use save_local, and you need to give the folder path. So this is the folder path that I am giving here as index store. Got it? If there is no index store, if there is no any existing index store, then we can do a save local directly. But if there is already an existing index store at the folder path that you are providing, then what it has to do, what this function will do is, it will first of all load that index. So it will first load the index, and then it will merge the new index that is created in these two lines. It will merge it with that, and then it will save the new the updated index into that same folder. So it is actually doing multiple tasks here, right? So it is loading, it is merging with the new data, and then it is saving the new data again. So these three steps is happening. This is how you do the incremental index loading in Faiss. This is one of the methods that I have used. If you have different method, do comment it out, but I find that this method is pretty simple to explain as well as to implement. This particular function also provides you the information that what has happened. Like once the merging is done, it will say merge has completed, because you might actually do a huge embedding also, right? And you may not know what is happening. So once the merging is completed, it will say the merge is complete, and if the index is already there, then the updated index is saved. If there's no index, then it will say that new store is created. So you will see that in action in a couple of minutes. After I do this activity, I need to check whether the embedding has happened and whether the data that I have sent into the index has been stored. So for that, what I do is, again, this particular function loads the index, and there is a primitive in Langchain where I can convert the entire index into a dictionary format. I convert it into a dictionary, and then I check the length of their values. I will show you in a couple of minutes how it works. So, and also one of the most important point I wanted to highlight here is that embedding. So this particular single line is what is actually calling the model from Hugging Face Hub. That is the embedding model from the Hugging Face Hub. It will know how to do the tokenization. It will know how to do the splitting. It will know all the processes. You don't need to do anything. And then after it does everything, you can actually you can use this embedding along with this particular step, along with this function as embed function. So this embed function will go with when you create the index store, when you load the index store, when you are going to when you save, you don't need it. But yeah, when you are going to create and load, this embedding function is required. So you see that everywhere. Let us go back to the PDF again. Now we have seen that how to get the embedding function first. Next, we need to feed the data to the embedding function. But now we have seen how to get the embedding function, and we have seen how the Faiss index works, how to initiate the Faiss instance, and how to work with saving it locally, working with the in-memory instance, etc. Next, what we are going to do is, we have already seen that how to modularize it, but now we are going to actually feed the data. So this is the part that we are going to do. So after we feed it, we need to test it and we need to search it at the last. Right, let us start that process. Let us go to this is a pretty long video because we have been discussing a lot of things in this. First and foremost, we are going to work with a simple text file. So this is the text file. I'll be showing you the text file here. Let me open it. This is a text file I collected from my existing mail. This is coming from IFTTT. That is if this then that.com, and you see it's a simple text file which has a lot of text in this, and I'm going to send this text file. I'm going to directly send the path of the text file into get text splits, and once I send it into that and I get this and I store the values into mail_docs, because it's mail collector, I am storing in mail_docs. And I immediately see that I have 50 elements in this. If I need to check the elements, all I need to do is mail_docs 0. If I do this particular checking, you will see that it is giving me the first split of the file. So like this, there are multiple splits that has happened, and you see that it is a simple text file. So this is how you see how that splitting is happening. Once the splitting is done, I take this mail docs and I send it to the embedding index. And what happens is that I give the mail docs, I give the embeddings function, this function, and then I give the mail index as the path. This is the mail index path. You see this here? Now what I'm going to do is, I'm going to create a new index, right? So I'm going to show it to you how it works. So this is a new index I'm going to create, and I'm going to press enter. So that this particular cell will get executed. So you see that new store is created, has the print has come here, and if you go into the folder, you will see that new index has been created. So if you open this index folder, you will see there is index.faiss and index.pickle. So this is a new index that has been created. And to check, so now you have created the index, you need to check it, right? How to check it? So for checking, there is a separate function that I have already created. And that function is, just a minute, the function is here, get docs length. So all I need to do is go use that function, come here, and just think about it. What should be the length? I mean, what should be the data length I'll be getting back? Just a minute, it should be 50, because we know that the number of documents inside the mail docs is 50, right? This is the length of the list. So here I'm going to say new index, and I'm going to say embedding function, the embed function is equal to embeddings. Once I do this, and once I press enter, I should get the index length as 50. So if you are getting a different index length, then there is something wrong. Either you have misunderstood the concepts, or the document did not split appropriately, or there could be various other reasons. So you need to check that. So this is an example where I showed with respect to one file, but I will not be doing this for rest of the files. I will be showing it only for this file because this is the beginning, right? But yeah, each of the file, now I'll be using new index. I will not use the existing mail index, because that is something that I use for testing this code. But when I am when I'm explaining this code, I'll be using new index for you guys to understand what is going on. So in new index, there is 50 documents right now. Okay, so before we actually go further, let me do one more thing. Let me first of all show you how to test the index. So let us say test index is equal to Faiss dot load local, and I say the local folder path is new index, and the embedding function is embeddings. Okay, this will actually create a Faiss index with the existing data. And next, what I'm going to do is I'm going to say test in index. It's not index anymore. I'm going to say search. So once you even type SE, what will happen is you will start getting this kind of automatic prompt pop-up from Jupyter Notebook itself. So I am using Collab. In Collab, it comes like this. If you are using VS Code, you will also get a similar kind of a pop-up. And I'm going to do a similarity search. In the similarity search, what I'm going to use similarity search, not a similarity. So what I'm going to do is I am going to search for space. Okay, let us see what documents gets returned. Space moon. Yeah, let us try. And you will see that immediately I'm getting the documents related to astronomy, picture of the day, and I get all the documents that have space inside it, and there is also one document that talks about the moon. This is what I was talking about. Assume that if this one document is actually big and it contains the entire mail, if it contains the entire if it contains this entire file, all the data inside this file, then what will happen? I will get only one document, right? I will not get for the space moon, I will get only one document. I will not get 4 documents. So anyway, so here it doesn't make sense, because most of the subjects are having space via IFTT, so it does not help me in any way. So let me actually try something else. Let me see whether I can work on constellation. That is something which we usually find it in astronomy. You see here it is different, right? You see different documents that is coming along with constellation. Now I say to the large language model that tell me about now I am going to say that tell me about tell me about stellar nursery in Perseus. What will happen is, so let me take this and place it here. See, what I am showing you how actually the large language model will work. This is something that I am not seeing a lot in the regular discussion, so I am sharing it with you in detail. So once I give this particular query to large language model using the retriever, so there is a retriever concept in Langchain. So do take a look at that. I have a separate video on that. But this particular context, all these 4 documents will go to the large language model, whichever large language model you are using, whether Cohere, Hugging Face, or OpenAI, whichever language model you are using, all this will go as a context, and the large language model will read it, and then it will provide the answer to your query. This is how it works, and you need to understand that how you do the splitting. So we saw that I discussed about how you here I discussed how we chunk size, how we do the overlap, etc. Right? Depending on that, your answer will come out correctly or wrongly. So keep this in mind. So with that said, I will go to the next step. So this is where I am checking it again. So I am using another one text file vim_play.txt, and I'm going to embed it. This time I am going to use new mail. So new index, right? This is a new index I'm going to do, and I'm going to do the embedding again. So first it will split it, and second it will do the embedding, and you see the merge has been completed. Now we can check the length of the Vim docs. So it is 22, and now if you check let us go back up here, and if you go and check this index, the length of the Faiss index that is already stored, you will see it is 72. So 50 plus 22 is 72. So like this you can check each of these things. So next I am going to do the indexing for the PDF document. And again, I'm going to use new index. I'm going to do the PDF split of self-ask.pdf, and it is going to take a little time for this. and then it is going to do the embedding. You will see the output here, and then we can check the, so this is a very big file, right? This is a 31 page file. It is doing an embedding, it is completed, and you will see the length of the PDF docs here. So it's almost 760, and then you can check the length of the new index here. So from 72 it would have become 832. So let me show you right now, because I'm showing it these things to you, that once you do the experiment by yourself, right, you should be confident that this particular code works. This is a CSV file. Yeah, this is something that I wanted to show it to you guys. So let me complete the process. This is a pretty straightforward process right now. Since it is modularized, we don't need to worry about it. But what I want to show it to you guys is how is the CSV docs available. So I was telling about the JSON format, right? So take a look at this CSV docs, the first element of the this particular documentation. You see this, the passenger ID along with the passenger the ID, home planet along with Europa, cryosleep, like this. So the CSV file is, where is the CSV file? The CSV file is in form of rows and columns. The column name is at the top. But when it is split by the CSV splitter, what has happened is it has become into kind of a JSON format. The column name comes along with the values. So this is the column name, the value. This is the column name, the value. So you can take it for any number of data. So I'm just showing it to you for the first 5 rows. So you see that repeating for all the rows now. So this is something that you guys have to be aware how it works. This is what I was talking about, and we saw that, and we can check the new index. So the new index would have added the CSV files. This is the repo. This is the same repo that I'll be sharing. This is the repo link of the repo that this particular code will be available. Okay, so I'll be sharing the link also. And here I'm taking the Python files, and so once I execute this, I will be getting the documents. So this will contain the snippets of Python files, and I will be embedding it. So I'll embed it right now. I already loaded it. It will take little time to go to the internet, fetch the data and do it. So I'm not doing it there. You can try to the other repos that and see how it works. It's pretty interesting actually. I did not know it is that easy. So this is one of the important concepts that you need to be aware, that any of your repo that you are having, whether it is local or whether it is in the internet, you can actually use it as a vector store and start querying it directly. That is extremely powerful, right? So here I am showing you with free open source embedding. It's not going to cost anything. But if you're going to use OpenAI embedding, be careful about the cost of the tokens. So and use it accordingly. And once it is done, you will see that the new index will have all the data from the Python code would have been already added here. So just for you guys to see what happens, let me actually show you the how the documents looks. Excuse me. Let me do this. Git docs 0. Once I execute this, you will see that the first document, whichever you are getting, will be the Python file. You can see let me print it. Probably that will be more clear for you how it is looking, because there are lots of you see this is a part of the Python file that is available inside this particular repo, and this is the embedding process that we followed. And this is the new Python, and here is this is the IPyNB file that I have got. This is already loaded here, and I am converting that into Python file, and then I am loading it here. So this is the process I am following here, and I can show you the Python file also, because it's already created. I will show it to you. So here is the Python file. I created it separately. Okay, this is something I created for showing it to you guys. But in case of this particular example, the file does not get created. This file is never created. The data in the file is available as Python variable or Python object, and that object is directly sent into the text splitter to split. So you will not see this file when you are running the code. So just for your information. Next is Excel file. So Excel file, the one that I'm using, has the target column as customers and the sheet name is database. And you see that when you see this page content, so you see the customer name, only the customer name is coming as document. Rest of all the information becomes the metadata. This is the one of the differences that I found very interesting in data frame loader. It does not happen in other kinds of loaders. So this metadata becomes very important. And also there is something called a self query retriever that has been released yesterday. That is on today. That is today, 28th of April. It was released by Langchain guys. That uses metadata very deeply. So just for you guys to know that this metadata is important, I'm sharing it to you. And this is how the Excel file works. And you can embed the Excel files because it's simply a text, and you can get the length. And finally, we have completed. Yeah, let us go back to the PDF. So we have completed all the documents. We have seen text, PDF, CSV, Excel code, all the files. We have seen how it works, and I have shown you how to test it, how to work with create a function to test it, and then I showed already how to search the vector store and verify that whatever data you want is coming out. So let me actually go back to the browser and show it to you again, just to show it to you that the data comes out. So let us take this particular name, Bernard, and let us go to this index, test index. Let me put it here and let me search it. When I do the search, I should, you see this, I'm getting the rows inside the vector store index, which contains the name or which contains the word Bernard, and it talks about that particular information, whatever is there. And something fishy is happening here. So you see that there is multiple places where Bernard Weatherly is coming, and for ID 1, ID 211, ID 467. Why is this coming? What is actually happening here? This is because there's a lot of data available inside the space shorten.csv. So the same passenger could have done a lot of things, right? So that is why you're getting this information. And also there is one particular data which we are not expecting. Why is Julian Merkel coming out? Because this particular word is actually some way close to Julian Merkel. This is mathematical relationship. It's not that there is no link between Julian and Bernard in semantic way, but mathematically, yes, they might have some distance which is actually closer, or the score might have come closer, right? All you need to think about is that first three should be perfect. This is very important. And if you are asked, how many times Bernard visited, how many times did Bernard spend on alcoholic wine, to large language model, all this data will get retrieved. The large language model will add up this information and provide you the final value. So this is how large language model will work. That's for information. And this is one more way to do the searching with score. So you see the score here. So let me do a score checking now. Since I was talking about that, let me do a score checking right now in front of you guys so you can understand. So you see this has the score of 0.577, while Julian has a score of 0.240. So by default, it is giving me 4 documents. And even though Julian has a lesser score, it is still provided to me. You can work with these things and filter. There are lots of ways to work with the documents. I'm not going to touch that aspect here, but I just want to let you know. With that said, we have come to the close of this particular discussion, where we have gone through the entire steps of working with various file types, splitting the files, the text into it, incrementally loading the files into the vector store, and then checking each of the file functions, and then verifying the vector store. So we have gone through the entire process. I hope that you understood the process of creating the embedding with various files. Do use it, use this video and try to explore further, experiment further. I hope that you like this content. Do leave a like and share it with others. Subscribe to my channel for further updates on similar kind of videos. I'll be continuously working on Langchain library, because that is having updates each and every day. Almost each and every day. And I'll also be working on open source related discussions on Hugging Face with respect to various other open source libraries like TXT-AI, 2V, Unstructured. There are a number of libraries that I've already covered, so you can take a look at that also. With that said, I would like to come to the close of this particular video with, as usual, 4 words. That is, and you guys have a lot of things to practice in this particular video. So the 4 words are practice, 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 practice. See you guys. Have a great time.